Okay, you guys, so we are starting our next little mini unit in earth science, and we're going to talk about climate change. So as you're following along with this, you're going to be filling out in your Cornell note sheet. So climate change, our essential question is, what is the main cause of climate change? So our vocab word today is climate, and we're looking at the change in climate. And we want to know, what is the main cause of climate change? Okay, so we are not disputing the fact here that there is climate change. We want to look at the causes of it. And to do that, we need a few definitions. So you guys just watched a very short video about weather versus climate. So sometimes, especially in these cold, snowy months, we get confused thinking climate change. What is going on with our weather? So like you learned in the video, weather is kind of a day-by-day change. So today it is a snowy day or it's a sunny day. Today it's really, really cold, but yesterday it was 30 degrees Fahrenheit. So these are going to be day by day. It changes often. Some days we have really nice weather and some days we have really poor weather. Climate is different in that it's going to look at the long-term trends in weather. So on average, deserts are really dry, arid places. On average, the North Pole is a very cold place. On average, the rainforest is going to have a very tropical climate. So weather is kind of that day by day. It can change. Climate is a long-term thing. Okay, we need to keep that in mind when we're talking about climate change. So we're talking about what are the trends over a long period of time. Okay, so that's what we're going to be looking at. So when we talk about climate change, we're talking about a long-term change in global regional weather patterns. We're looking at the change in hundreds and thousands of years. We're also looking at regional things, meaning that climate change can affect people in different ways, depending on which region or which area of the world that they're in. So the graph that we have here looks at temperature change since the most recent ice age. But if we look at the axes, this is thousands of years before the present. So right at the beginning, that's 18,000 years before the present. We can see all of those big changes. But again, it's not happening in 1 week or 1 month or even 1 year. We're looking at long-term patterns. So there are a bunch of different causes of climate change. We're going to look at a few of them. So one that people have talked about is solar radiation. So this is sunspots. So there are spots in the sun that are warmer than others. And when we have those hot spots that kind of shine down on us, it can be warmer. Sunspots, though, are things that come and go. So we wouldn't see an increased trend over time with sunspots. It would be for kind of a short amount of time. Other things, catastrophic events. So if there's a meteorite impact, that can change the climate in a certain area, again, for kind of a short period of time. Same with the volcanic eruptions. When Mount St. Helens erupted, it changed the weather, even in our area, for quite a bit of time, for quite a few years. But it kind of always goes back to the natural climate. The other thing could be humans. So a big thing that's happening is deforestation. So we're cutting down trees, which kind of changes the way that carbon dioxide is uptaken from our system. And then also trees give us the oxygen that we breathe. So if we have less trees, we're talking less oxygen. And then also our energy consumption. So the kind of energy that we use most often is fossil fuels. And fossil fuels, when burned, release certain chemicals into our atmosphere. So if we're looking at the kind of causes, there's two different things. Anthropogenic, those are causes because of humans, so something that we're doing. And then natural, these are things that happen over time regardless of if humans are going to be here or not. So you may have heard of this before, but the major cause for climate change right now is an increase in carbon dioxide, CO2, and this causes a warmer climate. CO2 is called a greenhouse gas, and greenhouse gases trap heat from the sun in our atmosphere. So in our last unit, we talked about the atmosphere protects us and it holds in heat. The atmosphere on Earth is perfect because it holds in enough heat and allows enough to escape that it doesn't cause us to overheat. So if we look at this drawing here, the cycle, the sun brings in radiation, and some of that radiation escapes. Some of it stays to keep us warm. The excess escapes. When we have more gases like carbon dioxide in our atmosphere, not as much of that energy is allowed to escape, and we get warmer. And we get warmer and warmer and warmer until eventually it's going to be too warm for us to really live the way that we do right now. So our key here is that more gases mean more heat. And so sometimes people talk about climate change as global warming. So global warming comes from this fact that the more gases we have, the more heat there is, and our climate will warm up. What we've learned though over time as we've studied this more is that we've changed it to climate change because when we have those warmer temperatures, it changes more than just the temperature. It has other effects as well, which end up kind of giving cooler temperatures in some places and warmer temperatures in other. So we're not just looking at warming here, we're looking at an overall change. So there is a lot of scientific data that talks about climate change. And so we're going to look at just a few graphs. What we're going to be looking for is trends. So trends is a pattern. So when we talk about trends, we're going to look at words like it goes up or it goes down, increase, decrease, stays constant. And so we're going to use some graphs to talk about trends. And we're going to use this kind of pattern. We're going to say as, and this is the first variable we're going to talk about is the x-axis, does something. So we're going to describe what's happening in the x-axis. We're going to use a pattern, so we'll use those trend words. And then we're going to say the y-axis and describe what's happening in the y-axis. So we're going to describe what's happening on the graph using the variables, the x and the y-axis, and then our trends of increase or decrease. So let's do one together. Now, there are a ton of changes on this graph, okay? So let's look at this. The figure description, it says figure 2.4, is going to give us information about what this is. So we're talking about atmospheric concentrations of CO2 on the top, CH4 in the middle, and N2O in the bottom. And I think we just pulled the CO2 part of this out. So we're looking at concentrations of CO2 over the last 800,000 years. So our x-axis, this is the horizontal, this is going to be time in years. Our y-axis is going to be CO2 concentration. And that's in ppm. ppm is parts per million. So if you had 1 million molecules of air, how much of it would be particles of CO2? Okay, so we can talk about two different trends with this. If we look at this first graph here, so we're going to look at this one, we can say that we're going to use our x-axis. So the time, as time increases